Calista, quickly coming over to you with my next question, that what is happening in RISC-V currently? If you'd like to share some stories about developments that are happening currently, that'll be really great.
So the very quick answer is I only know just a corner of what's going on in RISC-V because there's so much going on that I cannot keep up with it all, nor do I even know about it all until it hits the news. And the news is hitting every day. I hope if you haven't kind of tuned in to what's going on in RISC-V, I hope that you will. Let's just go back for a second to the explosion that we're seeing in the market. So, the predictions are that the semiconductor IP market will go from $5.2 billion in 2020 to $8.6 billion by 2025. So there's a lot of room right there for RISC-V. These are brand new workloads, and that's what we're seeing. And we are on course for the predictions that RISC-V will consume 28% of that market in IoT, 12% in industrial, 10% in automotive. These are huge double-digit fractions in percentages of an exploding market. And, we don't actually issue licenses. We don't negotiate contracts. We don't measure royalties. So that's where we don't even know everything that's going on. So here's a mistake that I made. This is, Calista fell down on her information. In December, we had our RISC-V Summit. And we did a quick calculation of how many RISC-V cores do we think were in the market in 2021. And I stood up on stage and I said, what, we did a quick count of what we think is going on. We think there are 2 billion RISC-V cores in the market in 2021. And Deloitte says, gosh, RISC-V is on fire and the RISC-V market is going to double in 2022. So I'm really excited. I'm like, in 2022, we're going to have 4 billion RISC-V cores. And Deloitte said, and they're going to double again in 2023. And I said, oh man, we're going to go from 2 to 4 to 8 billion cores in market by 2023. And I stood up and I was really confident about this. And then I was wrong, because then in March, Andy said, well, actually in January, Andy said, you know what, we were wrong. We thought we did this, but actually we went back and counted. We did, just Andy's did 3 billion cores in 2021. And then in March, they said, oh, we were wrong. We actually shipped 10 billion already. So we're shooting through all of these predictions, and that's just one company. That's just Andy's. NVIDIA has been shipping RISC-V cores with all of their products. Google has RISC-V cores. Facebook is using them in Oculus. You look at our roster, Intel has their own microprocessors already. Things are really taking off. From startups to multinationals. You think about who's getting involved in RISC-V. More startups than any other processor. More small companies, and we have hundreds of small companies that have invested in RISC-V as, this is our business. We're not even going to start with some of these other architectures. We are going with RISC-V from the beginning. In fact, we have a venture capitalist that has come into RISC-V International at a premier level because they are only investing in RISC-V companies. They have a $1 billion fund only on RISC-V companies. So if any of you are thinking about starting your own company alongside Siva and alongside me, there are many opportunities here. I have a call later today with another venture capitalist only investing in RISC-V companies in another part of the world. And I see this time and again. And in fact, we are really going now the full spectrum from Alibaba, who has declared a RISC-V strategy across an entire line of their portfolio that is open sourcing microprocessors for cloud and edge servers. to companies like Ventana and Rivos, who have come in as small startups, have joined our board of directors and have invested fully in RISC-V, to collaborations between universities. We have RIOS, a lab that is a combination of Berkeley and Tsinghua University. They have invested in RISC-V. To governments like the European Union and the European Commission and their EPI initiative, to India with the Shakti processor that has shifted onto RISC-V. These are fantastic validation points and sources of strength for countries, for companies, for investors, for multinationals, as well as entrepreneurs to start your journey with RISC-V. It doesn't need to be only RISC-V. You can do a both-end approach. That's what's making the skills that folks like Maven Silicon are helping infuse in the industry to jumpstart your career, to make your career portable. Be portable across architectures. Make your workloads portable across architectures. You will be invaluable to your investors, your board of directors, your employers, everywhere you turn in building your career. So we are really seeing it, the full spectrum of compute, from data centers and cloud and HPC to telecom. We have Huawei on our board. We have others that are engaged in 5G. Andes is working closely with SK Telecom. Google's Pixel 6 Titan M2 has hit the road to success as well. We're seeing it in automotive. So RISC-V is being validated to the very high standards of safety and security. We have things like Mobileye that are working on RISC-V. We have Imagination that is deeply involved with GPU linked together with RISC-V cores, meeting the safety critical standard certification. So automotive is a huge domain. All of these are possible because you no longer need to own the full stakeholder spectrum, from design to foundry to engineers to architectures to IP and everything in between. You see things otherwise in automotive like Europe's GA Next program that is helping to design power converters to ensure that you can continuously charge vehicles and that that's done efficiently. We have companies like Huami that have been engaged in RISC-V on consumer and IoT devices. Whether it's consumer or industrial, those IoT devices and acceleration and AI are the differentiators, the opportunity that is compelling companies forward. So take, for example, a large multinational. They want to compete in data centers. They want to compete in cloud. They're not going to do it just by scaling down or having more servers. They need to differentiate. They need a competitive edge. So they're adding on to their existing investments with AI or accelerated workloads. Adding on to an existing multinational investment is where RISC-V comes into play. You won't get very far in your career if you say, hey, let's rip out all that investment we've done in some other architecture and go to RISC-V. And that's kind of a career-ending move. If you say, we can compete effectively by adding this RISC-V differentiator to our existing investments, that's the path forward. And then let's talk future generations and shifting to RISC-V. And that's really what we're seeing, whether it's AI, the types of things that Siva is talking about with Esperanto, their 1,000+ core RISC-V AI accelerator. That is, the need for speed right there. Star5 has an AI visual processing platform. NVIDIA has been a huge fan and supporter of RISC-V since the beginning. And then you look at edge computing and the many ways in which high performance computing, the promise and delivery that those massive calculations can bring to everyday computing, or otherwise, kind of help to shore up those new workloads. That's really where we're seeing things take off. Let me just leave it there, but those are some of my favorite examples of what we see going on, and these stories are coming out every day.
Absolutely. Thank you so much, Calista. I'm sure that, with so much literally happening around, I'm sure that the world has really so much to be excited about. So thank you. Thank you again, Calista. Shiva, I have the same question for you that, what are our current ongoing plans when we talk about RISC-V?
Yeah, we are doing many things in RISC-V space. We have included RISC-V as part of our curriculum. So it's common for everyone, engineers, the new college graduates, corporates. So the beauty is actually every corporate engineer will also go through RISC-V as a case study. So as I mentioned, right, we walk them through processor design as part of our foundation course. For example, you look at how we train new college graduates. They come to Maven Silicon because they want to see themselves as chip designers. So what I do is actually I take them through processor design, and then I find out whether they are good for design or verification or DFT or physical design. So it's my responsibility to identify their strengths. If someone is good at logic design, yes, obviously they would be good for RTL design. But when it comes to verification, they need to have programming expertise. It's entirely different. So based on RISC-V, I classify them whether they are good for design, whether they are good for verification, or whether they can deal with something else like design for test or physical design. Right? See, that's the beauty. And we train more than 1,000 engineers every year. So the beauty is every engineer will go through RISC-V processor design. And also, we included a RISC-V as part of our corporate courses. From Jan 2022, I would say like we train more than 200 engineers for one customer. I'm not talking about 10 customers. For one global MNC, we train more than 200 engineers just from January. Right? So that's a big achievement. And we recently started with a RISC-V master learning program. We introduced this to one of our global customers. Currently, more than 50 engineers, they are taking up our courses, and they are looking at different aspects also, RISC-V design and RISC-V verification. If I look at new college graduates, I would say like till now, we train more than 1,000 engineers. We also offer internships for the engineers who want to learn only processor design. So that is something called a RISC-V internship. So these are all some of the things I love to share with Calista and then with you, Sweetie. Good. Yeah.
Great, great. So thank you so much, Shiva.